Hello everyone, and today we will learn about smart pointers. So basically smart pointers are like a new type of pointers that automate memory allocation and deallocation and reduce the risk of memory leaks and making the code more robust. What it means that it automatically does the memory allocation and deallocation. Like once the pointer is gone, it deallocates the memory on its own. So we have three main types of smart pointers: unique STD, unique PTR. Basically these all three of these pointers come into the namespace scope of namespace STD. So we have STD PTR, unique PTR, STD shared PTR, and STD weak PTR. Both three of them, each three of them have different ownership and reference counting mechanism. Let's learn about what is ownership. Ownership is basically, in a context of smart pointer, refers to the responsibility and control over a dynamically allocated memory, typically memory allocated in heap. Basically, what ownership in smart pointer means, that the responsibility and the control over the memory resources, like dynamically which memory is gonna be allocated to the program that we have written. It would like have the control over it, and it will be its responsibility to automatically allocate and then automatically deallocate. So there's like three of them have their own different ownerships. So let's start with the unique PTR. So unique PTR represents exclusive ownership of dynamically allocated memory. This means that any given time only one unique PTR can own a particular object. So basically this one PTR can only have like one object, like on only one object. Basically it's gonna only take the responsibility of one object, because it's on like unique, like you can remember it by unique. Unique thing is only one. So basically it only takes the responsibility of one object to allocate and deallocate memory of it. So we have a code over here about that gives us an shows an example of what unique PTR is. So we have made unique PTR. Since we already are using namespace STD, we don't have to write STD over here, but it does come in the namespace under the namespace STD, like as you can see here, namespace STD. So basically we have unique PTR. Then we have the type of what type of pointer it is. It's an int pointer. Then we have named it unique PTR. I can name it, let me put it as a name. Okay. This is basically going to be the name of the unique PTR that we have made, and this means that it will make the unique PTR equal to the int 42. Basically what it means, like let me explain it word by word. Make unique, and basically PTR is just invisible here, it means all that, and the type would be int to 42. So basically it means that make this unique PTR value equal to 42, and then we call it over here by counting. So then we have we call it by its by the pointer. Then let's see what we get. As you can see, we got 42, but right after the memory is this pointer is used and done with, it automatically deletes this whole thing. It automatically deletes the whole thing and deallocates the memory from the our like RAM. So this was unique PTR. Now let's learn about shared PTR and weak PTR pointer. Shared pointer or weak pointer. PTR basically is pointer. So let me pull up a code. Okay. So we have a simple code over here. Okay, so first learn what shared pointer and weak pointer is. Shared pointer basically allows multiple small pointers to share ownership of same dynamically allocated object. Basically, this shared PTR pointer would allow us to have the ownership, like allow the multiple smart pointers to share the ownership of the same dynamically allocated object. Basically, it would share the ownership with the other objects, other smart pointers, and then it would dynamically allocate the memory for the object. Object would remain the same, but the pointers would differ because they are like different smart pointers. So as you can see over here, we have node 1. We only like making for like, then we'll only making for node 1, then we're making for node 2. We're not doing node 1, 2 and 3 and all that in one. We're just making for only one. So after that we have weak pointer. Weak pointer basically complements this shared pointer we have and allows observing an object without affecting its reference count. So what this means, let's dig in a bit deeper about what weak pointer is. The ownership of weak pointer is used in conjunction with shared PTR. Basically both shared and weak are used together. It does not affect the reference count directly. Instead, it allows observing an object without affecting its reference count. So where do we use weak pointer? When you need to break cyclic dependencies that can occur with a shared pointer, it is particularly useful in scenarios when you want to avoid like strong differences that could prolong the lifetime of object. Basically, if you want to like, the point of these pointers are that we have to decrease the lifetime of the object right when it's stuck. Like when it's used, we don't want it to stick around anymore and eat our memory. We just want to get done with it. So basically we use it when to decrease the lifetime of the object when it's like not needed. So we have a code over here. First we have this structure that is named node. We have int data and then a shared PTR inside of it, which is next. Okay, so we have made two shared PTRs, basically this almost the same way. This is basically node is a data type which is like as you can call it like a tree of objects, like they're interconnected with each other. So basically node is like a you can even call it a point in a network or diagram at which lines or pathways interact or branch. Basically node is going to be basically a point in a network or a diagram where the different lines and or pathways will intersect and branch. Like basically either they will like come together to a point node or go away from the node, or both things. So we have made over here this node data type structure, So we have a shared pointer. We have the data type over here. Then we named it node1. Then we made a share. Then we like further explained the make shared pointer to this, and then we did for the next for the same data structure for the same structure, and then we did the thing. Basically, let me go nodes to kinda explain to you to like make it easy for you. Basically, this is basically the name of the whole thing. Okay, so basically this will come here. Okay, so if we have made a shared PTR inside the structure named next, so this is also another shared PTR. We made a shared PTR inside a pointer. So we have made these 2 pointers, then we have assigned these 2 pointers to the data. This is this operator. This is called this operator. Let me show you this operator. Basically what it does, it points to the value of anything that is in the code. So basically it is pointing the this node1 variable. Basically it has become a variable. It's a pointer of a variable. So it is pointing to this thing, to this data, saying that this is equal to 42. The node over here is 1 is the data, the integer data, which is equal to 42. Then we have do the same node 1 equal to basically is the next shared PTR which is a shared PTR, and equal to node 2, basically this whole thing. Then we are console outing the both of the things. We are console outing the data variable, and we are console outing the use count. We basically use count is a as you can see, it's declared in the std, is in the namespace std. It's declared in the io stream. Basically it just counts the objects. So let's run the code and see what we get. So as you can see, we got the 42 as the data we had here, and then we have 1, basically, which means that the pointer is only 1. Why it's only 1? Because once this wasn't being used at all, this wasn't really that much useful for us, so it got deleted. So basically it is saying that it only has value of 1 value, which is 42. So this was smart pointers. So basically why we use it, what are the benefits of smart pointers? Smart pointers provide automatic memory management, reducing the risk of memory leaks. This simplifies resource management, making code cleaner and maintainable. They enhance and save code safety by preventing common pointer related errors. So the best practices to practice these, the best practices to use these are, when using smart pointer, follow the best practices. Prefer the unique PTR pointer unique pointer if the exclusive ownership is needed. Basically, if you want to exclusively give ownership to one object and none other, not more than one or anything like that, use unique PTR pointer. Use shared pointer when multiple errors are required. Basically, we're giving multiple errors to a same object. Basically, this was the same object, but we are giving multiple errors. This, as you can see over here, there's multiple errors. Okay, and use weak pointer for breaking cyclic dependencies. So basically just making it like a cycle of variables. It's just to break that we use a weak pointer. Be cautious with circular references to prevent memory leaks. Okay, so in conclusion, smart pointers are very like essential tools for effective memory management and resource handling in C++. By mastering smart pointers, you will write cleaner, safer, and robust code. So this was pretty much it about all about smart pointers. Mostly about smart pointers. There's a lot more things that you would learn, which is a bit more advanced. I'm just giving you the basics of what smart pointer is and how you can make your own smart pointers and use them. So this was it for today. I hope to see you in the next one.